Hello, everyone. In this video, I will explain some of the SCT problems that student can do using the Desmos calculator so they can save their time in the SCT test. So for example, we have a problem number one, which is the equation x squared minus 8x plus k equal to 0 has exactly one solution. So what is the value of k, right? So the first step we do here in the Desmos is that we enter y equal to x squared minus 8x plus k. Let's say this has exactly one solution. So for what value of k does this equation will have exactly one solution? If we create the slider for k here, and so Desmos will create a slider like this. Now, think graphically, this equation means we are looking for the x-intercepts of the parabola for exactly one solution. The parabola must touch the x-axis. This is the x-axis here at exactly one point, right? So we want the parabola vertex to lie on the x-axis, right? And then if we move the slider here, we can simply move the slider until the parabola just touches the x-axis exactly at one point. Now we have 2 points, this one and this one, right? But we will move the slider such that it touches only one point. Oops. Let's say let's make k equal to 20 in this case, or 15. But let's say 18 here. Okay. Now it's up a little bit. Now, as we go down and see right here, now it touches the x-axis at exactly one point, this one. Okay. So, and that occurs for k equal to 16, right? So for k equal to 16, we have this equation x squared minus 8x plus k has a single solution, right? What is the set takeaway from this? So when a quadratic equation has exactly one real solution, think that the graph touches the x-axis once, right? Now let's move towards another problem, which is system of equation, right? Let's say we have a system of equation. We enter both of the equation in Desmos, so y equal to 2x plus 5. That is equation number one. And then y equal to x squared minus 3x plus 5. Okay. So we have two equations. One is the equation of a straight line, and another one is the equation of a parabola, as you can also see from the graph here, right? And then we find the intersection. So we click on the each of the point here. So this is the intersection point here, 0, 5, and this one is also the intersection point, which is 5 and 15. So therefore, the x coordinates are 0 for this one and 5 for this one, and we add them together, 0 plus 5 plus 5, which is equal to 5. So the question was, what is the sum of the x coordinates of the two intersection points, right? Now let's do another problem, which is exponential model. Let's say a population is modeled by an equation, which is p is a function of t equals equals A into 1.08 power T, where T is the number of years, and the population is 25,000 initially at T equal to 0. So what we do is the first step is that we have to do is to find out A from here, right? So at T equal to 0, so then we first put the equation y equal to 25,000 because that's the initial population, 1.08 power of x. Right? Now, and then we enter the target population. So approximately how many years will it take for the population to reach 40,000, right? So y equal to 40,000. Now Desmos display, um, it will display an exponential curve, as you can see here, right? So step 3 would be to find the intersection. This was 40,000. And we can find the intersection if we right here. Okay. And so finally, we will solve this for y equal to 40,000. So let's put 40,000 over here. That is equal to 25,000 into 1.08. Okay. If we click over here, then you can see that x is equal to 6.10703. So for x equal to 6.10703, y is equal to 40,000, right? So what does this mean? That approximately after 6.1 years, the population will be 40,000, as you can see from here. So these are the simple hacks for SCT math. I hope you liked it. So please like, follow, share, and subscribe. Thank you so much.